Hello everyone, today we're going to be solving question number 28 from the 2023 Mathcounts chapter competition sprint round. The question reads, if each of a, b, and c is the cube of some non-zero integer, what is the product of all the different possible values of this expression? Alright, so we're told that they're the cube of some non-zero integer, and then we're comparing for each of these fractions essentially the absolute value to the actual value. So that's going to be either a positive 1 or a negative 1, that kind of situation. And this is non-zero because you can't divide by 0. So cubes can be both positive and negative. So really what we're trying to figure out is how to solve it. So if we have like a is equal to, suppose, negative of the absolute value, which means that the absolute value of a is, since that's positive, that means a itself is negative. And then b is the same way. C is the same way. Alright, so technically, there would be 8 cases. That's where this is positive or negative, this is positive or negative, this is positive or negative, without really caring for any of the remainders. But we're going to consider them in a very systematic way. So starting here, we have these are all negative. You get this is negative times negative times negative. That becomes negative. And the denominator is always going to be positive. So negative 1. This one is negative times negative, which is positive 1. So that's plus 3 actually, because same for the remaining 2. And then these are all negative, so minus 3. So that gives you negative 1. Now let's try a equals negative. Absolute value of a, b is negative. Absolute value of b, and c is positive absolute value of c. Note that this covers all the cases where only one of them is positive because this equation is symmetric for each of a, b, and c. Alright, so the first one is a times b times c. So that's positive times positive, so that's positive, so that's plus 1. Alright, this one is going to be positive again, so plus 1. This one will be negative, so that's minus 1. This one will be negative, so minus 1. Minus 1, minus 1, plus 1. Minus 1, minus 1, plus 1. Okay, so this cancels with this. This cancels with this. This with this. So this is negative 1 again. Okay. Now let's consider the case where 2 of them are positive. Again, this is symmetric, so we don't have to consider other variations where only one of them is negative. Alright, so the first one is negative 1. Second one is negative 1, minus 1, plus 1, minus 1, plus 1, plus 1. So this plus 1 goes away, this minus 1, plus 1. This one goes away, this one goes away, this one. So that gives you negative 1 again. Alright, now let's make all of them positive. Oops. So all of them are positive, then all of these sums, so 1, 2, 3, 4, 5, 6, 7. That should give you 7. So product of all different possible values, so we have negative 1, that's the same for these two, and then this one is 7. So it should give you negative 7 as your answer.